right, how you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world. Today we're gonna keep on talking about theoretical probability of compound events. We're gonna do a few more samples, but before we do that, take this moment to go ahead and subscribe. And if you want to support the channel, link down in the description. If you haven't seen my other channel, MTV Alex, I'll leave a link over here. I do mountain bike and DIY stuff in it. Now, let's keep talking about this. Now, it says theoretical probability of compound events. We have previously talked about this subject before, and we actually work on this worksheet down here. I'll leave a link for you right over here. Don't forget to check that one out. That's the introduction for this continuation, so check out this link right here. Now, this one, we see something that we did not see on the previous video. And this is called, right here, what you can see right here, a lot of arrows and all that. It is called a tree diagram. Yes, just like a tree, okay? It branches out, because it branches out. It says, so each student receives one of 4 calculators model and 3 types of rulers. Fill in the diagram to show the probability of each receiving a type of calculator and a ruler. The first one in each row is done for you, okay? So basically, they're just giving you the fractions. Now, there's 4 different types of calculators and 3 different types of rulers, okay? Now, whenever we need to find the compound probability, to find the total possible outcomes, all we have to do is multiply those 2 numbers. 4 times 3, which is, yes, 12. So my total possible outcomes, my t, for remember this is still part over total, or the probability is going to be, the top of the fraction is going to be whatever you want to happen divided by everything that can happen. In this case, the total is going to be 12. How do I know that? 4 times 3. That's it. Now, it says, what is the possibility of the student getting a calculator? Well, there's 4 different calculators. There's 4 students. So each one out of 4, right? So that's why they have 1/4. Each one is going to get 1 out of the 4 calculators. That's it. Now the next one, the ruler, well, there's 1 out of 3, right? So the combination of getting calculator A and ruler A, B, or C is going to be calculator A, ruler A, calculator A, ruler B, calculator A, ruler C. Same thing with calculator B, ruler A, calculator B, ruler B, calculator C, calculator B, ruler C, so forth, so on. So the probability for the calculator, since there's 3 rulers, is 1/3, and all you got to do is fill it in. 1/3, 1/3. 1/3, 1/3, all the way to the end. That's it. This one you're just filling it in. Now to find the total combination, all you gotta do is multiply. Remember, you have 1/3 times 1/4, which is 1/12. That's how they got this number right here. 1/12, 1/12, all the way to the end. Okay, that's it. Now remember, to find the compound probability, you're gonna find the single probability for the first thing. In this case, is the calculator. To find the probability of the calculator, just find that. How many different calculators? 4. Each 1 student each, right? I mean, 1 calculator each student. So it's gonna be 1/4. And then the 3 rulers. Well, there's 3 different rulers, so there's gonna be 1/3. And to find the compound, all you gotta do is multiply straight across. 4 times 1 is 1. 1 times 1 is 1. 4 times 3 is 12. That's it. Now, use the tree diagram to complete exercise 2 to 4. It says number 2, what is the probability of receiving each calculator? What is the probability of receiving each calculator? We just got to look at this row, which is 1/4. What is the probability of each receiving a ruler? Let's look at this row, which is 1/3. What is the probability of receiving certain combination of calculator and ruler? 1/3 times 1/4, which is 1/12. Can't simplify that any further. That's the answer. That is it. Unless they ask you to convert to decimal or percent, you do that. TiVo. Now, let's look at number 5. It says 2 students are playing a game with a quarter and a spinner that is divided into equal sixths. So we have a quarter. So that's an eagle, supposedly, right? Face, heads, and tails. Okay. And then we have a spinner divided into 6 pieces. Right there. We have a spinner, 6 pieces. Numbers 1 through 6. We have 1, 2, 3, 4, 5, 6. How many outcomes are possible when you toss the coin? You have a coin, you're going to toss it. How many total possible outcomes? Well, you have heads and you have tails. So that's 2 total possible outcomes, right? Right there. How many outcomes are possible for the spin? How many numbers you have on the spinner? 6. That's it. How many outcomes are possible for the toss and the spin? List them. They want us to list them with the table or something like that. So you can get heads and 1, heads 2, heads 3, heads 4, heads 5, heads 6. Or you can get tails 1, tails 2, tails 3, tails 4, tails 5, or tails 6. How many total outcomes are those? That's 12. How can you find them easier without even label them? You do 6 times 2. You have 6 right here, you have 2 right there, multiply them, you get the total possible outcomes. Now, what is the possibility of getting tails and a 3? Let's look at it. Tails and 3 is only 1, right? So that will be, for instance, 1/12. Right? So if they ask you for something else, you can easily come up with that. So that is this one, tree diagram, and total possible outcomes on combined probability. If you learned something today, don't forget to hit the thumbs up button. Don't forget to comment, share, and subscribe. That is it for this one, guys, and I'll see you on the next one. Goodbye.